All right, ladies and gentlemen, today we're going to be continuing graphing using RATEY. Today we're going to be talking about removable discontinuity. It's also called a hole. It's when anything cancels out. So the first thing we need to be sure we do is factor. Factor the numerator, factor the denominator. Now, on number one, the only thing we can factor is the top. So I get x minus 4 and then x plus 1. And on bottom, I got x minus 4. So you can see that x minus 4's cancel out. And I just have the equation y equals x plus 1, which we know is a linear graph. My hole is going to be at 4, comma, and we're going to figure out what that is here in a second. So I'm just going to graph y equals x plus 1. So I start at 1. My slope is 1, so I go up 1 over 1, up 1 over 1, up 1 over 1. And then remember, at my x value of 4, I have an open circle. So I have an open circle there, and then everything else is the same. So then I just draw my line with my ID or whatever it's called, and boom, there we go. So my ordered pair was at 4, comma 5. For my open circle, my hole, my removable discontinuity, I didn't need to use RATEY at all. I only use RATEY when I'm doing rational functions. Let's move on to number 2. Okay, so on number 2, we needed to factor the top. So we can take out a 5. And so I get x minus 3, and on bottom I get x minus 3. And look at that, they cancel out. So I just have the horizontal line y equals 5, and I have that removable discontinuity at 3, comma, and it's going to be at 5, right? Because I know Hoy-Bucks tells me that at 5, it goes from here, then I have that open circle, and then keeps going. So I'm going to draw that open circle in at 3, comma 5. And that's it. We didn't need to do RATEY at all, so that's still NA. Don't need to do it. You only got to do it, remember, if you're doing any type of rational function. So we go on to number 3. This time I got 3 x's on top, 2 on bottom. Sorry, 1 on bottom, excuse me. So I got x, 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 1 on bottom. Those cancel out, so I get y equals x squared, and that's a parabola or quadratic function. The whole we set equal to 0, so that's going to be at 0. And then for a parabola, if you remember the parent function, the first point is 0, comma 0. So that's where my hole or discontinuity is. And I got 1, 1, 2, 4, 3, 9, and I'm just drawing the parabola. So we got our little parabola there, and that's it. Still didn't need to do RATEY. All right, so that's the last one that we're going to do as far as that don't need RATEY. From here on out, we're going to have to be using RATEY, so be sure you have that little piece of paper out that we used before. Okay, here we go on number 4. So we factor the bottom. That's going to be x plus 2, x minus 1. Those cancel out, but I still have a denominator, so it's 1 over x minus 1. So my discontinuity, or removable discontinuity, is at negative 2, comma, and we'll figure that out here in a second. But now I'm going to use RATEY. For the r, I don't set the top equal to 0. Or I do, but I don't get anything, so I don't have one, so none, or NA. Then my asymptote, set that equal to 0, I get 1. So my asymptote, vertical asymptote, is at x equals 1. Alright, so then we're going to go with tangency and togetherness. I don't have any of that. So NA again, remember for tangency and togetherness, we're looking for a squared somewhere. Squared on top, squared on bottom. Don't have that. In behavior, I have low over high. Low over high was 0 equals y. So y equals 0. And then my y-intercept, plug in 0, and I get negative 1. So 0, comma, negative 1. So 0, comma, negative 1, my end behavior is here and here. And then we get stuck, right? We don't know what to do. Well, think about this as a wall. So left side of the wall, I can connect my arrow with my dot. Boom, there. And then we're not going to go down because that wasn't together. Together means that around the asymptote, it's down and down, or around the asymptote, it's up and up. Well, since this one's going down, then that means this one is going up like that. All right. Number 5. Same idea, factor that. Now this one's a little tricky because you got something other than 1 for A. So I'm just going to go ahead and do it for us. So it's x plus 1 and, oops, sorry, 3x minus 2. So x plus 1's cancel out, and I get 1 over 3x minus 2. So once again, my whole is at negative 1, and I just realized I did not do the whole on the other one. Gosh darn it, there it is. So we forgot that at negative 2, I need that whole there, right there. And if I want to figure out what that exact point is, plug negative 2 in. So 1 over negative 2 minus 1, that's negative 1/3. So my whole is a negative 2 comma negative 1/3. Sorry about that. All right, don't let me forget on this one. All right, so root, we still don't have one because I can't set the top equal to 0. 1 cannot equal 0 no matter how hard I try. On the asymptote, I'm going to get 2/3, so x equals 2/3. I still don't have any tendency or togetherness, no squared on top or on bottom. And behaviors, low over high again, y equals 0. And my y-intercept, plug in 0, and so I get 0 comma negative 1/2. So negative 1/2 is there, 2/3. Do your best to squeeze that in there. Y equals 0 is there, y equals 0 is there. So now remember I have that negative 1 whole, so I think it's going to be right there because I got the arrow, I got this y-intercept, so yeah, it's right there, and then my other side goes there. And if I want to figure out what that exact point is, plug in negative 1 to that new equation, so 3 times negative 1 minus 2, so that gives us negative 1/5, which yeah, that's negative 0.2, so that's pretty close to being close to 0. All right, try number 6, pause it, and then we'll go over it. Here's your chance to pause. All right, number 6, see if I can find it here. Oop, going the other way. Just did all that. There's number 6. All right, so there it is, all done. It did not have a hole, so don't worry about that. We factor it, x minus 2, x plus 1 on top, on bottom, x minus 3, x plus 2. That means our roots are at 2, negative 1. Asymptote's 3, negative 2. We still don't have anything squared. Yes, we have an x squared, but when we factor it out, we don't have anything like squared up there, squared up there. Excuse me. Our end behavior is y equals 1 because I look at these, see how I got a circle so many times? Because this degree is 2, this degree is 2, so that means we just take our coefficients, 1 and 1, so y equals 1. Then I take 0, 0, 0, 0, put it all in there, and I get negative 2 over negative 6, which is 1/3. So then I get these 3 dots. Well, they're on either side of the wall, so like they're kind of on the inside of the wall. They're in this area. So I connect all 3 together, and then they just got to keep going down, keep going down. Since I don't have any togetherness or tangency, if this side goes down, then that means this side goes up. If this side goes down, this side goes up. All right. Good luck. We'll see you later. Bye-bye.